Today we will discuss about the critical region because this concept is also important in testing of hypothesis. So a critical region is a region in which the null hypothesis is rejected. So if a value of statistic which is used in testing the null hypothesis falls in critical region, H naught is rejected, and if it falls in the acceptance region, then this null hypothesis is accepted. So the area of the probability curve corresponding to alpha is nothing but a critical region. So a critical region is denoted by either C or it is denoted by C. Suppose if the value of test statistics falls in this region, so this is called as a acceptance. This is called as a rejection region. If any of my alpha which falls in this region is nothing but a rejection region. If any value of z which falls in this region is called as a, we have to reject the null hypothesis. And if my value of z, the value of test statistic, falls in this region, so that is we have to accept the null hypothesis. So the acceptance or rejections of the null hypothesis depends upon whether the value of the test statistic falls in the which region. So whether it falls in the critical region or the rejection region, we need to reject the null hypothesis. Now see, this is the level of significance and the critical region for the two-tailed test and one-sided critical region. What are given? So the level of significance is given. These are the regions of two-sided critical region, and this is one-sided critical region. Why this is two-sided critical region? Because this is the curve and I am taking the area of both sided. This is one side, this is the another side. Particularly we can say that this is a left side and this is a right side. Whereas in one-sided we are focusing on only one-sided area. So this is a left-sided area and this is the right-sided area. And for 5% level of significance, this area should be divided into two, taken as 2.5%, and this area is taken as 2.5% because the total area is 5%. If any of my value of z falls in this area or in this area, we have to reject the null hypothesis. Otherwise, if my value of z which falls in this area, then we can say that we have to accept the null hypothesis. So likewise, in case of one-sided test, if the value of z falls below this value, then we have to reject the null hypothesis. Otherwise, if it falls in this area, we have to accept the null hypothesis. On the same line, we can say that as far as a test is concerned, because in this case the alternative hypothesis is greater than or equal to, the region we need to focus is on the right side of the curve. If any of the value of z falls in this region, we have to reject the null hypothesis, and if it falls in this area, that we have to accept the null hypothesis. Now as far as 1% level of significance is concerned and two-tailed test is concerned, we have to take both sided area and we have to divide this level of significance by 2. That means this is taken as 0.005 and this is taken as 0.005, because half of this is 1%, then 0.5% is taken in this case and the 0.5% is taken in this case. And if any of the value of z falls in this area, then we have to reject the null hypothesis. And if the value falls in this area, so this is my acceptance area, if any value of z which falls in this area, we have to accept the null hypothesis. So this is all about two-sided critical region. What happens in one-sided critical region? The level of significance is 1%. So take all the area which is left side of this. We need to focus on the left side of area because this is a one-sided test and this is left-tailed test. So take total area 1% to the left side of region. And if any value of z which falls in this area, we have to reject the null hypothesis. On the same line, when it is a right-tailed test, if any value which falls in this area, we have to reject the null hypothesis. And what about the acceptance region? So this is the acceptance region. Any value of z falls in this area, or for right-tailed test, if any value of z falls in this area, so we can say that we have to accept the null hypothesis. Now we will focus on, now we will discuss level of significance. Probability of rejecting true H naught is called the level of significance. Probability of rejecting the null hypothesis when it is true is a level of significance. It is denoted by alpha. It is also the predetermined value of probability of type 1 error. So it is interpreted as the proportion of cases in which H naught is rejected though it is true. And level of significance cannot be made 0. However, we can fix it in advance. Either it is taken as 1% and 5%. In most of the cases, it is taken as 5%. It means that 5 out of 100 cases, it is likely to reject true H naught. Now focus on the p-value. P-value is nothing but the probability that the value of test statistic is at least as extreme as its computed value as the basis of the sample data under H naught. Right-tailed test, the p-value is the area of right of the computed value of the test statistic under the null hypothesis. And as far as this left-tailed test is concerned, the p-value is the area to the left of the computed value of the test statistic under H naught. The p-value for two-tailed test is twice the area on either tail, left or right, of the computed value of the test statistic under H naught. And this is the most important condition, that if the value of p-value is less than alpha, we need to reject the null hypothesis. If the p-value is greater than alpha, we do not reject the null hypothesis. That means the decision is taken either by calculating the test statistic value or the p-value. If calculated value of z is less than table value of z, we do not reject the null hypothesis. And if the calculated value of the test statistic is more than the table value of test statistic, then we reject the null hypothesis. That is one case. In another case, if we calculate the p-value, if p-value is less than alpha, we reject the null hypothesis. And if p-value is more than alpha, we do not reject the null hypothesis. So we will stop here and continue with some other terms in test of hypothesis in the next video. Till then, goodbye.